This is our lesson 6 from computer systems called Factors Affecting the CPU. Remember, we are following the GCSE Computer Science specification J277 OCR. So before we look into the factors which affect the CPU, imagine I am going to ride a Formula One car. Okay. Before I put myself into that car, what do I need to know? I need to know the engine power, the weight, the aerodynamics, the transmission, the tires, the fuel quality, the terrain, and the mechanical conditions before I will set my foot into that car. Similarly, the CPU is affected by certain factors. These factors are clock speed, cache size, and number of cores. What is speed? What is clock speed? Clock speed is the number of pulses the central processing unit generates per second. The clock speed measures the number of fetch, decode, execute cycles that can take place in 1 second. The faster the clock speed, the more instructions can be fetched and executed per second. So the clock speed is measured in hertz. Modern computers have a clock speed in gigahertz, meaning billions. A clock speed is 3.5 gigahertz, can perform up to 3.5 million instructions per second. So, overclocking. So let's look at overclocking. Sometimes people can overclock their CPUs. What is overclocking? Overclocking is a process of forcing your computer to run faster than it's intended to go. You can overclock both your CPU and graphic card, which can help you run advanced programs on an older PC. But although overclocking is largely safe, it's possible to run into overheating and crashing issues. What are cores? Now remember, cores are CPU is known as a core. Okay. So a CPU core is a processor within your computer that executes instructions and processes data, is essentially the brain of your computer. Each core is capable of fetching, decoding, and executing its own instruction. The more cores a CPU has, the greater the number of instructions it can process in a given space of time. So, number of cores. A core works like it is its own CPU. Multiple cores processor mean they have multiple separate processing units that can fetch, decode, execute instructions at the same time. For example, a dual core would have two processing units, which will each have their own control unit, their own ALU, own accumulator, and own register. Number of cores. Multiple core processors can run more powerful programs with greater ease. Multiple core increases the performance of the CPU by working with the clock speed. So, for example, a quad core will run how? It will be 4 cores multiplied by 3 billion instructions, and that would be 12 billion instructions per second. So, how do the core work? How do these core work in a CPU? In order to share data, the cores are connected by channels. As you can see here, they are connected by channels. So 2 cores will have 1 channel, 3 cores will have 3 channels. So they are connected by channels. Important data can be sent from one core to another. A dual core has 2 CPUs. So it appears to be operating system as 2 CPUs. This means parallel processing can take place with 2 or 4 instructions being executed simultaneously. Multiple cores could work on different programs that operate in parallel, but unless a computer is designed to use multiple core, a quad core isn't 4 times faster. So, what does that mean? That means that unless and until your computer can handle multiple cores, it will not run faster. So, your computer should be able to handle quad core. Similarly, as you can see in, you will see here on the slide, you can have dual core, quad core, hecta-core, octa-core, and deca-core. So to increase the performance, manufacturers add additional cores or CPUs. Cache memory. So let's look at cache memory, which is quite important. A cache is high speed memory that sits close to or can be directly on the processor. Cache is very small, very fast memory on or close to the CPU. Cache is used as temporary storage to provide quick access to a copy of frequently used instructions and data. So this line is extremely important. Quick access to a copy of frequently used instructions and data. First of all, I hope by now you understand the difference between instructions and data. Data are raw facts, and instructions are what are you going to do with those raw facts. Example, if you were making a cake or baking a cake, you would have your data, your measurements as your data, and instruct recipe, what to do with it would be your instruction. Okay. So the larger the cache size, the more frequently used instructions or data can be stored. This results in the CPU having to complete fewer fetch cycles from RAM, speeding up the performance. The cache, as you can see, when running programs, computer system is constantly swapping data in and out of cache memory. When an instruction or set of instruction is frequently used, it is inefficient for a processor to fetch these from RAM each time. To overcome this, cache memory is used to store the instructions that are likely to be called upon. As with RAM, cache memory is erased when power is removed. Cache is also has a significant faster read write speed from RAM, making it much quicker to retrieve information from there instead of memory. So, what does all that mean? All that means is that if I had said, if, say, for example, I was trying to do addition, I was going to add stuff to my computer. Okay, I was going to add 8 plus 2, and later on I was going to add 10 plus 5. Later on, I'm going to be using 15 plus 20. So, what am I doing? These instructions, what are these? These are ALU instructions, which I am constantly using. So, how does this work? So, to understand this whole process, the CPU is constantly fetching decoding instruction, and it has got cache, which is sitting here. Okay, the cache is sitting here. So, what happens because I am constantly using the ALU, the accumulator, it will, instead of going to RAM, it will ask cache every time. The CPU will go to cache rather to RAM. In computing terms, RAM is far away, although it doesn't look to the human eye. It is. So if I'm using these instructions, which are mathematical instructions, it will go to cache, because what is this saying? Cache is using a set of instructions. So it says set of instruction is frequently used. set of instructions which are frequently used. So what am I frequently using in this example? I'm using plus, plus, plus. So it makes no sense for it to go to RAM because it is using this instruction. So cache, the CPU control unit automatically checks the cache for instructions for requesting data from RAM. So it automatically checks cache first. So because I'm doing these calculations, it will check cache first before it goes to RAM. That's what it is saying here. This saves fetching the instruction and data repeatedly from RAM. A typical PC in 2020 might have 8 or 16 GB of RAM, but only 2 megabytes of faster, more expensive cache memory. So, as it says here, a typical multi core arrangement for level 1, level 2, and level 3 cache is this. You can pause the video and take some notes how it looks like. Again, let's understand the difference of between parallel processing and multitasking. I did mention multitasking previously, so let's understand what it means. Parallel processing is when a multi-core CPU will process multiple instructions from a single program at the same time. Some programs, however, are not written to allow more than one instruction to be processed at the same time. Multitasking is where two or more tasks, different programs, instructions at the same time. So, what does that mean? That means if I have got 30 windows open on my computer, but I will only be working on one at a time, although it is giving me an illusion that I'm working on 30 windows, but I'm not. The CPU is only working on one task. It is giving me an illusion. That's why it's called multitasking. How does multitasking work? So, this is all running programs and data are stored in RAM. Only one program, task, process can be run at a time on a CPU, which I explained you earlier on. When the allocated time has ended, the process is blocked. The current values stored in registers on the CPU will be saved in RAM when the process is not running. So, this is a question from your exam paper. It says, does doubling the number of cores make your computer twice as fast? So, this is the answer. The benefit of having a multiple core is that they can run a program designed to run instructions in parallel at the same time. Increasing the number of cores will make a computer faster. Therefore, unfortunately, the cores have to communicate with each other and have to take their turns when accessing the cache and RAM, all of which uses up some of the potential speed that adding more cores gives you. So, although doubling the number of cores theoretically doubles the speed, in reality, the computer will always run slightly slower than that. Actual cores themselves are not necessarily faster. However, because there are more cores, it means that more instructions can be processed over the same period of time. So, to recap, what are the factors? The factors are clock speed, factors are cache size, factors are number of cores. Exam question. So, let's look at an exam question. The CPU has a clock speed of 3.8 gigahertz. Describe what is meant by clock speed of 3.8 gigahertz. So, to answer this, you could have said the number of fetch, decode, execute cycles run per given time or second. Okay. The next question is, Alicia says my computer has a quad-core processor, so it will run twice as fast as a computer with a dual-core processor. Explain why this statement is not always true. Remember, I answered this in my previous slide. Some of the software may not be designed to run on one or multiple cores. Clock speed also affects speed. RAM size also affects speed. And cache size also affects speed. Next question. Carrie is looking at two computers. One has a single core and the other has a dual core processor. Explain why having a dual core processor might improve the performance of the computer. So here you can answer it like this. Dual core is two processor. Parallel processing can take place. Okay. Also, each processor can run a different part of the program at the same time, which enables multitasking. So keyword multitasking. Some processors cannot be split between two processors, so it does not increase the performance. Next exam question, and this is the last one we are going to look at. One computer has 64 kilobytes of cache and the other has 512 kilobytes of cache. Explain how the cache size can affect the performance of the CPU. So what does the cache do? Cache stores frequently used instructions. Okay, so this is what we discussed. This is what you could have answered, which means more cache improves the performance of this CPU.